Hey everyone. Okay, so we're moving on and further into Unit 1. This video is going to cover factor quadratics and also other factoring techniques. And I believe there's a couple of worksheets that go in here somewhere along the way. And so keep an eye out for those because there might be a worksheet due before these actual Knewton assignments, or it may be that you do a Knewton assignment and then a worksheet and then another Knewton. Okay, so pay attention to that as we go through this so you'll know what order to do those in because they're assigned as we cover the corresponding material. Okay, makes sense? All right, so this is all about factoring. We're going to go through several different factoring techniques. Now, you may have learned something in the past, in high school, in a previous math course, and if you are good with your factoring technique, I'm not going to ask you to reinvent the wheel, but the methods and the strategies that I show here is how I'm going to work things all semester long. So factoring is not a strong suit for you. I would really encourage looking into doing it the way I'm going to show. That way it stays consistent throughout all the videos and your homework. Okay? All right. So when we talk about factoring, we're going to look for several different things. We're going to look at the number of terms something has, and that helps us determine what factoring technique to use. Okay? Now, before we start any factoring technique, we always want to look for greatest common factor, okay? This is always our number one thing that we look for, okay? And what a greatest common factor is, I'm going to go ahead and write it in right here, is basically the largest number and or variables that can be divided out evenly from each term. That can be divided out evenly from each term, okay? The largest number and or variables that can be divided out evenly from every term. So like, is every term divisible by 2? Does every term have an x? Does every term have a y squared? Things like that, okay? So you're looking for that common thing that they all have. So that's what we do first. We always pull that out. Then we look at how many terms we have in the polynomial. So we talked about terms in one of our previous lecture videos. And so if we have 4 terms, we're going to do grouping. If we have 3 terms, we're going to use the SumProduct chart. And if we have 2 terms, we're looking for a sum and difference of squares or cubes. Okay, so we're going to go through each of those in a little bit of detail. So the first one is just this finding the greatest common factor. Okay, finding that thing that they have in common. So here are examples. So if I have these different expressions and I want to know what do all of these have in common, the first thing is I look at the numbers. Okay, I look at 25, 50, 5, and 15, and I notice that they're all divisible by 5. So I know my number part of my greatest common factor is going to be 5, right? And I can't take out anything bigger than 5 because this one only has a 5, right? Then I look at my variables. So I look at my A's. Notice they all have an A. So I want to know how many A's do they all have in common? Well, this one has 2, this one has 3, this one has 1, and this one has 4. So the most that all of them have in common would just be 1, right? Because once I take the 1A out of this one, he doesn't have any more A's to have in common. So that means I can only say they have 1A in common. And then I look at the B's. I have a B squared, a B to the 5th, a B to the 4th, and a B cubed. So when I look at those, how many B's do they all have in common? It would have to be a B squared, right? So basically I look to see what common letters, right, or variables they have, and then I take the lowest of the exponent power. So this is going to be 5ab squared. And so this is my greatest common factor for these different expressions. Okay, so I want to do the same thing on this one. So when I look at this one, I have 45, 99, 63, and 9. So when I look at all these numbers, I like to look at the smallest one and the biggest one. That's kind of my little shortcut. So I'm looking at 99 and 9. I know they both have 9 in common. And I also know that 99 is just 9 times 11, right? And these other 2 numbers are not divisible by 11, right? Nor is 9 divisible by 11. So the only thing that all 4 of these numbers can be divided by evenly is 9. So my number part's going to be 9. And then I look at my x's and my y's. and I take the number that they all have in common. So they all have x's, and my smallest x exponent here would be x to the fourth, right? So that's the most that they could have in common. And then I look at my y's. They all have y's, and my smallest y exponent is a cubed. So this is my greatest common factor. Okay, I'm kind of okay. So that's just identifying the greatest common factor. So if you see the word find the GCF or the greatest common factor, this is all you're doing. You're just stating what it is. Okay, now if you see the words factor out the greatest common factor, this means you're identifying the GCF, or the greatest common factor, and the leftovers. Okay, and I'll show you what that looks like. So we're not only identifying what the greatest common factor is, we're going to write what's left in each term once we take that greatest common factor out. Okay, so just like before, I'm going to look at these and see what do they have in common, right? The smallest number is 8. 8 does not go into 70. So I need to think a little bit smaller. What else goes into 8? Well, 4 goes into 8. But 4 doesn't go into 70, right? So I'm going to think even smaller. So 2 goes into 8, and 2 also goes into 70. So my greatest common factor, I'm just going to write it to the side. I know it's going to have a 2, and then I look at my y terms. The smallest of my y terms is y to the fourth. So I can say that they both have a y to the fourth in common. Now this is my greatest common factor, but that's not my answer because they asked me to factor it out. Okay, so what that means is once I factor it out, it's like I'm dividing 2x to the fourth off of each term. Okay, so we can use our exponent properties to simplify this, right? Or we can think about taking 4 of the y's away from this term, right? And then dividing it by 2. So this is how we're going to write it. We're going to write our greatest common factor, 2y to the fourth, and then in parentheses, we're going to write what's left from these two terms. So on the first one, 8 divided by 2 is 4. Y to the fifth divided by y to the fourth, or if I take 4 of the y's away, I'm just going to be left with 1y, right? Same thing on the second term. Go ahead and put my plus. 70 divided by 2 is 35. And I'm taking 4 of the y's away. And notice that's all this one has. So it doesn't have anything else left over. So we just leave it like this. If you want to check your answer to make sure you did these correct, all you have to do is redistribute this. And if you redistribute it and you get what you started with, then you know you did it correctly. Okay, I'm not going to require that you check your answers, but if you want to, that's how you would do it. Okay, so let's look at another one. Same idea. We need to find the greatest common factor of 45, 33, and 78. So again, I always look at the biggest and the smallest. 33 is the smallest. Now 33 is 3 times 11, right? So I'm just going to write that here. This is the same thing as 3 times 11. I know 11 doesn't go into 45, and I know 11 doesn't go into 78. So the only possible thing that they could all have in common, if they have a number in common, would be 3. Okay, and they are all divisible by 3. So I'm going to go ahead and write here that my greatest common factor is going to have a 3. And then I look at their letters. So they all have x's in common. The maximum x I can take out of any given term is a squared, so I'm taking out x squared. And then they all have y's in common, with the smallest exponent being a y cubed. Okay, so this is my greatest common factor. So just like we did on the last problem, I want to go ahead and write my greatest common factor, and then I want to write in parentheses what's left over when I take this out of each term. Okay, so again, you can write it underneath here, 3x squared y cubed, 3x squared y cubed, 3x squared y cubed, if that helps you, or you can just do it in your head. Okay, when 45 is divided by 3, it leaves us with 15. We're taking 2 of our x's away, and we started with 5, so that leaves us with x cubed. We're taking away y cubed. We started with y to the 7th, so that leaves us with y to the 4th. And then our second term, if I divide 33 by 3, I'm left with an 11. If I take away 2 of my x's from the 3 I started with, I just have 1 x. And if I take away 3 of the y's and I started with 3, I don't have any y's, right? My last term, when I take 78 and divide it by 3, that's going to give me 26. I'm taking out x squared, and notice I only had an x squared, so no more x's in that term. And I'm taking away 3 of the y's from the 4 I started with, which means I just have 1 y left over. Okay. So that's my final answer on that one. Okay, are we kind of okay with the process? All right, so on the next page, there are 2 for you to try. So I want you to go ahead and pause the video and take a minute. On number 1, notice you're just finding the greatest common factor, right? On number 2, you're factoring out the greatest common factor. So take just a second, pause the video, and then play it, and I'll display the answers, okay? All right, ready? Okay, so on number 1, the greatest common factor should have been 3a cubed b. And on number 2, your greatest common factor should have been 6x squared y squared. And when you take 6x squared y squared out of all 3 terms, in your parentheses, you should be left with 7x to the 6th plus 5y plus 3x cubed y squared. Okay, everybody good? Okay, so that is the first step of factoring. Anytime we factor, we always start with the greatest common factor. Okay, now once you've taken out that greatest common factor, what's left over in these parentheses, we might be able to factor further. So that's what we're going to look at now, is our factoring strategies of that piece that's left over. So the first thing we're going to do is identify how many terms does that piece have. If that piece has 4 terms, then we're going to use factor by grouping, okay? And factor by grouping is basically a method of finding the greatest common factor, or the GCF, of 2 terms at a time, okay? Then factoring out their leftovers as a common factor. Okay, so this is the method of finding the greatest common factor of 2 terms at a time. So this is for 4 terms. So we're just going to look at a pairing of 2 terms and 2 terms, okay? And then once we found the greatest common factor of each of those pairings, then hopefully whatever's left in the parentheses as their leftovers, we can then factor out, okay? So let me show you what that looks like. So on our first example here, remember we always look for a greatest common factor first. So 8, 10, 12, and 15. Do these have anything in common? Well, I look at my biggest and my smallest usually. So 8x squared and 15. Number-wise, these don't have anything in common. So since these 2 don't have anything in common, I know all 4 together don't have any numbers in common, right? And if I look at their variables, they don't all have x's and they don't all have y's. So I'm just going to write out to the side that there's no GCF, okay? That way I know, I don't have to worry about it, okay? All right, so I'm going to go straight into the grouping process. And to factor by grouping, basically I want to pair the first 2 terms together and the second 2 terms together, okay? Now, out of the first 2 terms, I'm looking for a greatest common factor. So what does 8x squared and negative 10x have in common? Well, 8 and 10 are both divisible by 2, and they have x's in common. So my greatest common factor for just these 2 terms would be 2x, okay? So I want to go ahead and, sorry, let me focus this. There we go. All right, so I want to go ahead and take a 2x out of just those first 2 terms. So when I divide 8x squared by 2x, that's going to leave me with 4x. When I divide negative 10x by 2x, I'm going to be left with a negative 5, right? I don't know why my thing keeps unfocusing. There we go. All right, so I've done the first 2 terms. Now I'm going to forget about the first 2 terms for just a second, and I'm going to move on to my second terms. Okay, so looking at just these 2 second terms, what do they have in common? Well, 12 and 15 are both divisible by 3, and they have a y in common. And you have to write if you're taking out a positive or a negative greatest common factor. I'm going to go ahead and just take out a positive 3y. And if that doesn't work out, then I can go back and try it as a negative. So if I take out a positive 3y, I want to know what is going to be left over in my first term. So 12xy divided by 3y is going to leave me with a 4x. Okay, and then when I take negative 15y and divide it by 3y, Well, a negative divided by a positive is going to stay negative, and I'll be left with a 5. Okay, so all we did was basically the greatest common factor strategy for each of those pairings. So now that I've taken the greatest common factor out of one and taken the greatest common factor out of the other, what I'm looking to see is if these leftover quantities match. And notice here they do, which is the hope, right, when we're doing these. If they don't match, you might have done something wrong or need to tweak a sign or something, okay? So now that these are the same, I'm looking at this as one big term and this is one big term, and both of these terms have a 4x minus 5 greatest common factor that I can take out. So if I take out 4x minus 5 as a greatest common factor, in parentheses, I write my leftovers, and what's left here is going to be just a 2x, and what's left here is a positive 3y. And now I am completely simplified, okay? All right, so now that I'm completely simplified, that is my answer. If you want to check your answer, all you have to do is just redistribute this back out and see if you end up with the terms you had here, okay? All right, let's look at one more, and then I will have y'all try some, okay? All right, so first thing we do right off the bat is always, always, always look for a greatest common factor, okay? So when I look at all 4 of these terms, I don't see any variables, any letters in common, but I do see that all 4 terms are divisible by the same number, which in this case would be 3, right? So I'm going to go ahead and just put a star over here that says there's a GCF of 3. And the reason I put a star is so that when I get done with my problem, I don't forget to put that greatest common factor in with my answer, okay? So I'm going to go ahead and take that greatest common factor of 3 out. And when I take it out, remember I divide it out and write in parentheses what's left over. So here what I'm going to be left with is AB minus, when I divide 18A by 3, I'm going to get negative 6A plus 6B divided by 3 is 2B, right? And then when I divide 36 by 3, I'm going to be left with a negative 12. Okay, oops, sorry. There we go. All right. So now that I've taken this 3 out, I'm just going to forget about it for just a second. I mean, it's good to put a star there just so you remember to put it on your answer, but for the sake of working this problem, we're just going to kind of ignore it for a minute so that we can go ahead and factor out the 4 terms. Okay, so I'm going to pair them 2 at a time. So looking at my first 2, the only thing these 2 have in common is an A. So I'm going to take out that A and in parentheses write what I'm left with. So when I take an A out of this term, I'm left with a B. When I take an A out of this term, I'm left with a 6. Okay, and then I move on to my second pairing. These pairing share the common factor of 2. So I'm going to take out a positive 2. Be sure you write here whether you're taking out a positive or a minus, because if you forget that sign, you're going to miss a sign in your quantity of your answer. Okay, so when I take out a positive 2 here, that's going to leave me with a B from this first term, and when I divide negative 12 by 2, I'm left with a negative 6. So just like before, we're hoping that our leftovers match. Here they do, so we can actually take our leftovers out of these 2 terms as a greatest common factor. So when I take out B minus 6 out of this first term, I'm left with just A. And when I take B minus 6 out of the second term, I'm left with just positive 2. So this is completely factored, and then I just have to remember to put my greatest common factor down here on the front. And then that's my answer. Okay? All right, so I want to give you guys some to try. So on the next page, there are 2 for you to try. Let me get to the next page here. All right, so there are 2 for you to try. So go ahead and pause the video so that you can work through these 2 problems, and then unpause it and we'll go through the answers. Okay, good luck. All right, you ready? So on number 1, there's no greatest common factor, so we're going to go ahead and write no GCF so we know we don't have to put anything in our answer. And we go straight into grouping. So we group the pairs of terms together. The first one we can take out a y. The second one we can take out a positive 5. So when we take that out of each of those pairings, notice our leftovers should be 2x minus 1 and 2x minus 1. So we take out that 2x minus 1, we're left with a y from the first pairing and a plus 5 from the second pairing. So that is my answer. Okay. On number 2, we do have a greatest common factor, which is 4. So before I get started with grouping, I want to go ahead and take that 4 out. And in parentheses, once we take that 4 out, we're left with 2ax plus ay minus 2bx minus by. And now we can go ahead and go into grouping. Now, if you forgot to take out this greatest common factor first, and you already have some answer down here of 2 factors, one of them you should be able to pull the 4 out of. So if you forget to do it at the beginning, you can do it at the end as long as you remember to check. Okay, so don't erase everything. If you forgot to take that 4 out, you probably have the right answer. You just need to take a 4 out of one of your solution quantities. Okay, all right, so once we take the 4 out, we have our 4 terms. We group them by pairs. The first pairing we can take out an A. The second pairing we want to take out a B, but notice over here we ended up with a positive 2x and a positive y. If I just take out a positive b over here, these 2 terms are going to stay negative. And if these 2 terms stay negative, they're not going to match this quantity. So instead of taking out a regular b, a positive b, I'm taking out a negative b. Because when I divide out a negative b, it's actually going to change the signs, because a negative divided by a negative is going to leave me with a positive leftover. Does that make sense? Same thing here. A negative by divided by a negative b, negative over negative is going to leave me with a positive y. And now my leftovers will match. I can take those leftover quantities out, and then from my 2 terms, I'm left with a and minus b. Okay, and that's not my answer because I had a greatest common factor of 4, so I have to remember to put that back on the front of my solution quantities. Okay, all right, so that is what we do with 4-term polynomials. We always look for greatest common factor first, and then if we have 4 terms, we go into grouping. Okay, so now what I want to look at is what do we do when we have 3 terms. When we have 3-term polynomials, this is on the same page, just a little bit further down, we want to go ahead and use this method called the SumProduct chart. Okay, we're going to do this little chart, and what it is, or what we're doing, is this is just the method of replacing the middle term, so that we can factor by grouping. Okay, method of replacing the middle term so that we factor by grouping. So if I have 3 terms and I can take this term out and put 2 in its place, then I'll have 4 terms, right? And once I have 4 terms, now we know how to do that. That's just our factor by grouping. So we're going to create this little chart, and it's going to help us decide what should we take this out and replace it with. Okay, so let me show you what that looks like. Here's an example at the bottom. Again, we always look for a greatest common factor before we start doing anything. So our greatest common factor here, well, we don't have one, right? They don't all have numbers in common. They don't have variables in common. So I'm going to go ahead and just write off to the side, no greatest common factor. Okay, so I want to go straight into the SumProduct chart, and I'm going to go ahead and just label it S and P for sum and product. Now our sum is always our middle coefficient. Okay, so our middle coefficient here, the number part of this term, is a -1, right? There's an implied 1 here, and since it's negative, our middle coefficient is a -1. And my product is always my first coefficient times my last coefficient. So here my first coefficient is a 2 times my last coefficient, which is a -6. So 2 times -6 gives me -12. So my product is a -12. Okay, so here's how this chart works. Now that we know what our sum and our product is, we want to find 2 numbers that satisfy those 2 things. Meaning, I need 2 numbers that multiply to give me -12, but that sum or combine to give me a -1. Now 2 and -6 doesn't work, because even though when I multiply 2 and -6 I get -12, if I were to combine 2 and -6 over here for my sum, I would get a -4, so that doesn't work. So I need to go ahead and determine what works. In this case, it's going to be 3 and 4, right? 3 times 4 will give me the 12 I need. One of them needs to be negative. And if I want to end up with a -1, then the 4 is the one that's going to have to be negative, right? 3 times -4 gives me -12. 3 combined with -4 leaves me with a -1. So this is the pairing that I want to use, okay? So what I'm going to do with these two numbers is I'm going to use them to replace this middle term, okay? So instead of using -1x, I'm going to rewrite this, 2x squared. Instead of my -1x, I'm going to write in plus 3x minus 4x minus 6. Okay, it doesn't matter which order you write this 3 and -4 in right here. What does matter is that when you replace that middle term, whatever the label was on that middle term, you need to make sure your two new terms have the same label. So here my label was an x, so I need to make sure both of these are labeled with an x. Okay, all right, and now we can do what we did just in that last little section of factoring by grouping. So when I factor this by grouping, the first pairing only has an x in common. And when I take the x out, I'll be left with 2x plus 3. And out of the second pairing, remember, I'm hoping to get this left over. So if I want to be left with 2x plus 3 here, what I'm going to have to take out of these two is going to have to be negative, right? Because I have two negative terms. And I need to divide out a negative so that I end up with positive leftovers. Okay, so I know this needs to be a negative, and what these two have in common is a 2. So if I factor out a -2, I just want to double check, -4 divided by -2 gives me that positive that I need. -6 divided by -2 gives me that positive 3 that I need. So that worked, all right? And now my leftovers in these quantities match. So I take out my 2x plus 3, and I'm left with x from the first term and -2 from the second term. Because I had no greatest common factor, this is my final answer. Okay? All right, let's look at a few more, same idea, just using this chart to find the product and sum of two numbers that I can replace this middle term with. Okay? So, next example. All right. So here, same thing. First, look for greatest common factor. In this case, they don't have any numbers in common. They don't have any variables in common. Now, some of you may have learned to factor out a -1 anytime your leading coefficient is a 1, and that's fine, but you don't have to, okay? So I'm going to go ahead and go straight into my sum product chart. So sum product. So my sum is my middle coefficient, remember, which here again is a -1. My product is my first coefficient times my last coefficient. So my first coefficient here is a -1 times my last coefficient, which is a 42. And -1 times 42 gives me a -42. So I am looking for two numbers that multiply to give me -42 that I can combine to get -1, right? So those numbers would have to be 6 and 7, right? I need to multiply a 6 and a 7 because those are 1 apart. And if I want to end up with a -1, the 7 is the one that needs to be negative. So 6 times -7 gives me the -1 that I need. So I'm going to take these two numbers, 6 and -7, and replace this middle term. So I'm just going to rewrite -x squared. Instead of -x, I'm going to write plus 6x minus 7x plus 42. Okay. I'm sorry, my little camera here just keeps not focusing very well. All right, and now we can go straight into grouping. So out of the first pairing, the only thing that these two have in common is an x. So I'm going to go ahead and just take out an x. When I take out a positive x, notice this term's still going to be negative. So I'm going to be left with a -x plus 6. And out of the second pairing, 7 and 42 are both divisible by 7. And I can either take out a positive 7 or a -7. If I take out a -7, my leftover is going to be positive, and I really want it to match this one. So since this one starts with a -x, right, I want to be left with this. So if I start with a negative and I want to be left with a negative, then I don't want to take out a negative because that will change the sign. So I'm going to take out a positive 7 here. Okay. So that way when I divide negative 7x by 7, I'm left with my negative. And when I do 42 divided by 7, I'm left with a positive. Okay. And now my leftovers match, so I can go ahead and bring them out. And I kind of ran out of room. So negative x plus 6. My first pairing is left with an x. My second pairing at positive 7. And because we had no greatest common factor, right, we had no GCF, then that means this is my final answer. Okay? All right, let me look at 2 more and then I'll let y'all practice some. If you feel like you're good on the process, you can go ahead and skip forward to the practice problems. But I want to show you a couple more if you just need a little extra practice, okay? All right, so let's look at this one. We look for greatest common factor, and this one, unlike the others, has bigger numbers, right? So don't be scared with bigger numbers, same process. So 4, 19, and 21 have nothing in common. So I'm going to go ahead and say over here there's no GCF. So I'm going to go ahead and create my table, SumProduct. My sum is always my middle coefficient, which here is a positive 19, and my product is my first coefficient times my last coefficient. So negative 4 times negative 21 gives me a positive 84. So I need something that I can multiply to get 84 that I can combine to get 19, okay? And we have one pairing here. We have 4 times 21. Well, those two combine not to give me 19, right? If I do 21 minus 4, it's smaller than 19. So I want to think of other things I can use to get 84. Okay, so notice up here, if you're not sure, you can do 84 divided by 1, 84 divided by 2, 84 divided by 3, until you find a pairing that gives you 19. Or you can use the factors you already have, like 21. 21 is divisible by 3 and 7. So I could go ahead and do 84 divided by 3 or 84 divided by 7 to try to get some other pairings. In this case, I want to use 7 times 12. 7 times 12 gives me 84, and 7 plus 12 gives me 19. And I don't have to change their signs because 2 positives works. So I have 7 plus 12. Okay, so these are the 2 numbers I want to replace this middle term with. Now, like I said before, you can enter these in any order that you want. So when I rewrite this, I have negative 4x squared and I have a negative 21, and I want to put these 2 numbers in. Well, I could just go ahead and put my 7 first and then my 12, or I could switch it. It really doesn't matter, okay? So do what you feel is best. Just don't forget that when you put those numbers in, they need to have the same label as your middle term. So I'm going to do plus 7x plus 12x, okay? All right, so now that we've replaced our middle term, we have 4 terms, and we can go into grouping. So when I group these 2 together, I can take out only an x, right? That's all they have in common. So if I take out an x, I will be left with a negative, whoops, let's make this focus, a negative 4x and a positive 7, right? Now I want to see what these 2 have in common. Well, these 2 are both divisible by 3, so I know I want to take out a 3, but it's important to know what kind of 3. Right now I have a positive term, and if I divide a positive by a positive 3, I'll be left with a positive. And notice, I really want my leftovers to match this one. So I want to be left with a negative here, so I'm going to take out a negative 3 instead. That way when I do 12x divided by negative 3, I'll be left with negative 4x. Does that make sense? Okay, and then negative 21 divided by negative 3 will give me the positive 7 that I needed. And now that my leftover quantities match, I can take those out. So negative 4x plus 7, and what I'm left with is x and minus 3. I had no greatest common factor, so that is my solution. Okay. All right, I got one more to show you, and this one's a little bit different because before we ever start, notice we have a greatest common factor on this one. On this one, all terms have an x, and all terms are also divisible by 2. So I'm going to go ahead and put a star and say we have a greatest common factor of 2x. So before I get started, I want to make sure I pull out that greatest common factor. So when I pull out a 2x, 6x cubed divided by 2x is going to leave me with 3x squared. Negative 40x squared divided by 2x is going to leave me with negative 20x. And negative 14x squared divided by 2x is going to leave me with a negative 7. Okay, so don't forget about this GCF we have on the front. We want to make sure that ends up on our answer at the end. Okay, so now I want to go ahead and move on to trying to replace this middle term. So over here to the side, I'm going to make my sum product chart. My sum is my middle coefficient. Don't go back to your original. Use your new one, okay, because you took something out, so these numbers are all different. So negative 20 is my new middle term, or middle coefficient, sorry. And my product is now 3 times negative 7. 3 times negative 7, which gives me negative 21. So if I need two numbers that multiply to negative 21 that combine to negative 20, I would have to use 21 and 1, right? And I need it to be negative, which means one of these has to be negative. So if I need one of these to be negative and I have to end up with a negative 20, then it's the 21 that needs to be negative, okay? So I have a negative 21 and a positive 1 that I'm going to replace this middle term with. Okay. So I have 3x squared minus 21x plus 1x minus 7. Okay. Don't forget to label these numbers with the label from that middle term. Okay. And now we can group. So out of the first grouping, I can pull out a 3x, and I'm left with x minus 7. And out of the second term, they actually really don't have anything in common. So if they don't have anything in common that you can pull out, there's one thing that you can always pull out that won't change the value, and that's a positive 1. So I'm going to go ahead and pull out a positive 1, because dividing by 1 doesn't change anything, which leaves me with x minus 7. Okay. And now that their leftovers match, I can go ahead and take that out, x minus 7, and I'll be left with 3x from the first pairing and a positive 1 from the second pairing. 3x plus 1. And then I just have to remember to put that greatest common factor back on the front. I'm going to put my 2x out front. And then I'm done. Okay. All right, so on the next, or the bottom of this page and the top of the next one, there are two problems for you to try. So go ahead and pause the video and work through the practice problems 1 and 2, and then go ahead and play it when you're ready to check your answer. Okay? All right, so here's number 1. Number 1, we have no greatest common factor, so we go straight to our sum product chart. Our sum is our middle coefficient, which is 8, and our product is our first coefficient times our last. So 3 times negative 3 gives me a negative 9. So the correct pairing you should have chosen is 9 and negative 1, because that multiplies to a negative 9 and combines to a positive 8. Okay, so when we replace our middle term, our 8x, with 9x and negative 1x, we should be able to group it correctly and end up with the quantities x plus 3 and 3x minus 1. Okay. If you didn't get that, go ahead and pause the video and go back and check your work. If you did get that, let's look at our second practice problem, which here we had a greatest common factor, right? All of these terms are divisible by 3. So before you ever get started, you need to go ahead and pull that 3 out. Now, once you pull that 3 out, it leaves you with x squared plus 9x plus 20. And then that is what you will use to do your sum product chart. Okay, so I'm going to leave this here for just a minute so that you can check your answer. You should have ended up with 3 times the quantity x plus 4 times the quantity x plus 5. Okay, now if you forgot to pull out this 3, don't erase your entire problem. Okay, if you forgot to pull out this 3 and you ended up with just 2 quantities, one of these quantities should have a greatest common factor of 3, and you can just pull it out here at the end. Okay, but as a rule, always look for your greatest common factor first. Okay, all right, now you'll notice in your notes it says worksheet factoring quadratics. So we have done enough lecture at this point for you to complete this worksheet. So it is now due. Okay, we haven't gone through enough material for you to do the first Knewton assignment yet, so hold off on that, but you should be able to do this worksheet. Okay, so go ahead and get that done. If you're not sure about that, check Blackboard. That's where everything's located, and you can find your worksheet in your assignments, okay?